Hello, people. Welcome back to another session on .NET Web APIs. So in today's session, what I'll be covering up is creating the entity models uh, based on the tables which we had created in our previous session. I will also be giving you a quick overview on the generic repository pattern and the unit of work pattern, which we'll be using to communicate with our database, along with the lightweight ORM Dapper. Okay, to begin with, let me just show you the generic repository pattern structure. So I have a class diagram here. So what we'll be creating is we'll be creating an interface called iGeneric repository, which will have generic constraints. Okay, so it will have declarations for methods like get async, get by ID async, add async, update, delete, etc. So this repository. So this interface will be basically used by all the entities. So it's like a generic repository. So there be any table or any entity, all the basic CRUD operations will be there in this repository. Okay. Now, if you see, according to the structure which we have the companies table and employees table. So based on that, uh, there are two more interfaces which inherit from the iGeneric repository. One which is iCompany repository of company, and iEmployee repository of that employee. So these interfaces will be for specific methods. Apart from any of these CRUD operations, if a particular entity needs to have certain complex logic of getting records from the tables, so those will be supported by this interface, company repository for companies, and for employees, it will be iEmployee repository. Okay, so now there will be a concrete uh, class for implementing all these, that is the generic repository of T. And further, there will be concrete classes which inherit from this as well as this. So if you can see the structure here. And on the right hand side, we have an interface called iUnit of work, which will have basic methods like begin transaction, commit and close connection, rollback, etc. And again, it has a concrete class which will be implementing it. The role of unit of work pattern here is to maintain the RDBMS properties, the asset properties like atomicity and consistency. That is, whenever we have any write commands or write queries which go to the database, which usually change the state of the database, uh, it's good to use a unit of work pattern, wherein if you are making multiple queries to the database, out of which, say, suppose one query fails, then your database is left in an inconsistent state. So to avoid that, we have the unit of work pattern, wherein if you are adding records to the table or updating records, you have to use the unit of work. So you have to begin the transaction. If it is successfully completed, so if it is successful, you say commit. If there's any exception or error, you use the rollback method, so which will completely roll back. So the database transaction will be atomic. So there will be either completely successful transaction which is happening or completely failed. Okay, so that will prevent inconsistent data. So now if you see here, the our unit of work interface will have references to all these specific repositories, that is company repository, employee repository, so that you can use it how it's shown in this code snippet here. So you first create the instance of the unit of work class, pass in the instance of the depot context class. So this we'll all see this in the upcoming tutorials where how we can create the depot context class. Then if we need to get any items, we use it in this way, unit of work dot companies dot get by ID async, and then pass the GUID. Similarly, if you want to add any record to the database, it will be using this approach where you first begin the transaction, you add the company, and then you commit. So once you do commit, the changes will be actually reflected in the database. Okay, so being that said, let's move ahead and now let's start creating the models. So now if you see, I have the organization.domain project, which has a folder called common and models. So I've already created a model here called an interface called IDB entity, which has the ID property. So all the domain entities which we'll be creating will be inheriting from IDB entity. So now if we move back to the model which we had already created in a previous tutorial, that is company, model, and company. So we had just created this for demo purpose. Now let's go and actually create the implementation which we want. Okay, so let's remove this. So this company model entity will be inheriting from IDB entity. So we'll be using this. And now let's create, since it is inheriting, it needs to implement the ID. So, so now based on what records are there, what columns are there in the table, we'll start creating the properties. Okay, so we have a name property, so we'll create that. Then we have a address column, so we'll create the address property. We have a country column, we will create that. Similarly, we have the is deleted column, so we can go ahead and create that. There's also the paging order column, but I usually prefer not to include those in the model because those are just used for uh, functionality of paging. So when we move to that session, when we will be doing paging, we'll be using that. So for now, let's have this model set. So now, since we have the properties ready, I usually, since we are not using entity framework and we are using Dapper, I usually like to follow this approach wherein I create custom attributes for the properties as well as entity models so that I can put in the table names to which it is associated to and the property names to which it is associated so that when we use the generic repository approach, uh, it works well with that. So what I'll do is I will go ahead and create an attribute called table name attribute. So I'll go to domain utilities. So domain common, and inside the utilities folder, I'll create a class. So this is how you actually create custom attributes. We call it as table name attribute. So custom attributes, it's inbuilt feature of C#. And this is the standard naming convention which you follow. You you prefix it with the word attribute. So let me create this here, table name attribute, and it should inherit from the attribute class which belongs to system namespace. Okay, let's make this public. So I will put in the constructor. So if you see, it will accept the name value and it is assigning it to this property. So another property which the property or the attribute which we need to provide is the attribute usage. So whether this attribute will be used on a class or a property. So since this is a table name attribute which will be used on the entity model classes, we limit the target usage to class. Okay. And the way this can be used is we go to the company model which we have, and we can use it here as table name, which is the attribute. And then whatever is the table name which we have in the database, we use that. So we mention that here. Okay. One more thing which I just missed is the models, which whenever I create models, I prefer to use a sealed keyword so that it's clear that if any new developer who's joining in does not inherit from this class. So we have prevented the inheriting of this class. So I prefer naming or creating a model entity model classes as sealed. Okay. So now we have created this. Another property which we can create is the navigation property. So since the company's table has a child table with foreign key references for employees, and the company can have multiple employees, we can create a navigation property as well, which is IEnumerable of type employees. So let's go ahead and create the employee entity model as well. So we follow the same approach. We'll have a new folder called employees, and we'll create a folder called models. Let's create the class employee. So just remove this. Let's make it as public C employee, and it will inherit IDB entity. So now let's add the properties which we need. So based on the columns which are there in the employees table, we will have the properties accordingly. Okay, since we have the employees model created, so now what we can do is just use Since we have this navigation property now, now let's go ahead and create a custom attribute for the properties. So I will go ahead and create the custom attribute and name it as column name attribute, where we can supply the actual column name so that we know which property a particular which column a particular property maps to. Okay, so let's have the implementation. Now, if you see the attribute usage, I've limited it to property. So we can go ahead and use this over here. So we can use this as column name, and we supply the name which is used in the database. In this case, it's ID. Okay. In this way, we can create and map it for each column which we are using. So name, address, country, deleted. Yeah, there are a few more custom attributes which I'll create. One is for the primary key, one is for foreign key, and one is for the navigation association which we have. Let's create the primary key. Have the primary key attribute. And let's also create for foreign key so that we can use it in the employees entity. And this will also be targeting the properties and have the attribute usage property set. There's one more which we need to create, which is the navigation attribute. And the navigation attribute will have two input parameters. One is the type which it is associated to. I'll tell you what exactly it means when we will be using it. So let's create this. So if you see, this will have two input parameters. One is associated type, which is the which is of the type, and it will also have a string input, which will be the associated property. So let me show you what I actually mean now. So we have this company's entity model. So we can now decorate the ID property with primary key attribute, and we can decorate the employees navigation property with the navigation attribute, and this will take in the type of the foreign key table or type of the child table, which will be employee type, and it will take the foreign key property name, So it will be the property name of the child entity, that is in this case company ID. Okay, it will be the property name of that, which will be specified here. So similarly, we will complete this here. We'll add the table name attribute for this, and we'll complete this as well. Okay, so we'll have the primary key, all the columns set, and we'll also have the foreign key for this. And similarly, here we'll have the navigation property set. One more thing which I will do is I'll create a short GUID utility. So basically, I prefer my GUIDs to be short and have the length which I specify. So if you see when we had created the table, the column size which we had given was 22 characters. So let's limit our GUID to be small. So what I'll do is I'll be creating a short GUID. So let's use that even for this, create the implementation now. So what we can do is in the utilities folder itself, we can create a class called short GUID. There's no inbuilt short GUID class. There's the system namespace will have the GUID class, but it will be longer than 22 characters. And that's the reason we are creating own utility class. Okay, now let's implement this class. Okay, so it's a basic implementation where it will take the substring and make it to 22 characters so that we can use a short GUID. So now if you see, the red squigglies are gone because we have defined the class which we want. So that's pretty much it, I guess. So we have our entity model structures created and ready. One more item which I would like to cover is I'll create some utility extension methods which we'll be using in the next tutorial. So what that will be doing is in the repositories, we'll be using extension methods to map the properties of the model entity with the respective column names and the respective table names. Okay, so let's create a static class called extensions inside application utilities, because application common utilities folder. This is because these extensions can be used uh, across the application. That's why I'm putting it in the application project. So let me create a static class called extensions. Let's add that, and I will just go ahead and create the classes which we need. You see here, we have implemented the method which we need. So we also need to create an associated type, which we just missed. We will also create that. Let's go to the main common and let's create a class called associated type. what this associated type class will hold is it will hold the type and foreign key property. So if you see the extension methods which we have created, they are basic extension methods like get DB table name based on the type. So in the generic repository which I just showed you, we'll have a generic type. So based on that generic type which is provided, what it will do is it will try to get the table name based on the uh, attribute which we have provided to a particular model entity. Okay, so it will get, so this is basically using a reflection, so it will get a particular table name. Similarly, it will get column names. And so if you see this here, it is getting the DB table column names. So, so it is based on the type, and you also pass in the selected properties. So this is the implementation for this. And similarly, I have other extension method which are implemented. So one is get column values for insert. So in case we are inserting, and for update, I have already created get column values for update. Then there's another method, extension method here, get DB column name by property. So this all will be clear when we'll be actually implementing the generic repository, how we'll be using these methods there. Then I have another extension method for is lower invariant, which is used here. If you see, then we get column properties. So it's basically using reflections, and there's also another method called get non-primary key column properties. Okay, so the reason why we are doing this is what we'll be using for implementing the communication with the database is stored procedures. So we'll be using something called generic stored procedures. So let me start creating those stored procedures. So let's go to the database project. Let's go to the database project, and inside stored procedures, let's start creating stored procedures. So first stored procedure I will create is for getting the records from the table. So by generic stored procedure, I mean it may be any table from which you are getting the records from. May it be the company table or may it be the employee table. It will be using this same generic stored procedure to get the results. Okay, so let me name it as SP get records or SQL. And so this is the standard naming convention which I follow when I create stored procedures. I suffix it with an SP, like how I suffix TBL for tables. Similarly, for stored procedures, I suffix it with an SP. So if, let me create the stored procedure. So if you see the stored procedure, let me delete this and paste in the implementation of the stored procedure. So the stored procedure will take in the have two parameters, table name and the columns. Okay, so and it will run a dynamic SQL query using SP execute SQL, which is a system stored procedure. So it will select from columns which are passed, or if the columns by default will be null. If it is null, then it will use star from the table which is supplied. And this is what we mean by soft delete. So it will use the soft delete feature. That is only if the is deleted column is 0, it will pull the records. Okay. So this is how we'll be using a generic stored procedure. wherein if you want to, you can add, insert, you can add, update, delete, as well as get records which are associated to any particular table. Okay, and let me create all the stored procedures which are needed. One is SP get records. I'll create another one for getting a particular record by the primary key, that is getting by ID. So let me call it as SP get records by ID of SQL. Delete this, insert here. So this will again have table name, columns, and the primary key, which is the ID, as the input. And based on that, it will again form a dynamic query, and it will run it using the SP execute SQL. Similar to that, we'll also have SP insert record table. Let's create that. In this case, it will again take the table name. But now what extra it will do is it will take column names and column values, okay, to run this, to form this dynamic SQL query and run it. So insert into table name, and the column name will be passed in, and the column values will also be passed in, which will be coming from the API by using Dapper. Okay, let's also create similar kind of stored procedure for update. So we'll call it SP update record. The update record.SQL. Again, update will also do similar stuff. It will have the table name as input parameter, columns to update, and the ID on which the update needs to be performed. And we'll also have the stored procedure for the soft delete. Let me just create one for that, and I'll call it an SP soft delete record. Let's create it here. So this will take in the table name and the ID. So based on that, so if you see the query, it's not actually a delete, it's a soft delete. That means it's updating the particular uh, entity records whose ID is passed in, and setting the is deleted column to 1. There is another stored procedure which is associated to the soft delete functionality. That is, in case if we have a table with relationships like the company and the employees, where company is the parent table and the employee is the child table, and uh, if you want to soft delete entries from the child table when the parent table entry is soft deleted, we can create a stored procedure for that, which is called, we'll just name it as SP soft delete for key record. Soft delete you see this, so this will be SP for the foreign key record. So the way we will be doing it in Dapper is we'll first delete the record from the main entity, and uh, if we choose to delete from the child table when the parent entry is deleted, we can use the stored procedure wherein again the table name will be passed in, foreign key column name and foreign key column values, so which will then uh, update the foreign key or the child table and set is deleted to 1. Okay. So I'll go ahead and also create another stored procedure. I will name it as SP get total records count. So this stored procedure will be basically giving us the number of records in the table. So this will be specifically used when we are working on pagination to get the maximum number of pages which we can use. We'll call it as SP get total records count. It's doing nothing but just giving you the count of records based on the table name which is supplied. So these are the generic store procedures which will be used. So basically, if we want to do any kind of CRUD operation, we can do it using just these store procedures. And apart from that, if there is any other complex queries which are needed, which are apart from the generic CRUD operation, we can create stored procedures separately for that. Okay, so now since we have created this, one more thing which I will just touch upon again is the extension methods which we have created. So if you see the extension methods, this one will get the table name based on the type. This one will be getting you the table columns. So especially in case of uh, the properties. So based on the properties, it will get the column name so that we can actually form the, so these extension methods, all these extension methods are used for getting the string values of the parameters which need to be passed to these generic stored procedures. Okay, so as we get along with the upcoming tutorials wherein we create the generic repository, you will get the actual usage of these extension methods. So that's it from this tutorial. In the next one, we will actually start building the generic repository and the unit of work pattern structure and make our API actually run and do the basic CRUD operations on our API. That's it from this tutorial. Bye.